So whatever I speak from now on gets recorded, so we can push this out, and then of course you can take a look at it later. Okay? So when you want to try out this basic workshop, you need the Eclipse IDE. That's the basic IDE. Of course, in the next demo, you will see that I'll start using a better IDE, which is Spring Tool Suite, STS extension of Eclipse. So this is the only to make sure that I'm able to run it on an IDE, and I'm able to sort of troubleshoot it if required quite easily. Some of you are IntelliJ fans, some of you like NetBeans, so whatever is your IDE you can pick. But I stick to Eclipse because we have a larger, stronger community of help there. So the Eclipse J is basically the cloud version, really cool for Kubernetes development. And there are many companies which are trying to come and bundle the whole kind of Eclipse tools very specific to their clouds. Like Orion Cloud has their own version, Amazon has their own Eclipse version, and so on and so forth. So there are different variation from the cloud vendors as well. I'm just going with the plain one for starters, and later on I'll move into Spring version when I'm trying to do the Spring Cloud demonstration and so on and so forth. So this is basically the plain version that comes. So when I download it, it basically comes in as a zip file, a self-extracting zip file. So let me show you how the file looks like, so that you can sort of navigate it when you have to look into it. So you can see that inside the installers I would have it. So this is the file, and you can see I sort of tested it 2 days ago. So I used to use the old version because I want to set up for the class. I was testing it earlier. So this is a self-extracting exe. And when you install this, which I usually do inside my Eclipse folder, you can see that it creates an Eclipse folder like this. And then this is your normal Eclipse installation. The only problem that I wanted to talk about when my mic was off is when I start this IDE, you can see that it keeps saying that I'm using version 8 and not version 11. So to just explain it to you, I went into the system settings. I go to the environment variable. If I go into the path, you can see that the default Java home is JDK 8. So for some reason it goes and picks up the default Java home. Okay, so that's how Eclipse is designed. Even if I hard code it like I just now did, right? So you can see that I directly hard coded the JDK 11. It still doesn't start on JDK 11. Okay? That's because somehow Eclipse has a habit of picking the JRE home. Okay? So that is what I was trying to talk about. So there's no point going and setting up all the path. Okay? So in fact, I'll go and put back my path, which I just deleted. So I'll go back here and then say new, and maybe move this up as well. So move up, before Scala. Okay? So I'll just leave this path whole thing around. Okay? So the important point to note here is your INI file. So this fella has to be a bit hard coded. Okay? So that is where the trouble is. So if you look at this file, and this is what I was trying to explain when I realized my mic was bonkers. So you can see that everywhere it keeps saying requires 11, requires 11, right? So what you got to do is you got to point your virtual machine to a folder where there is this installation that is pointed to 11. So what I have to do is I have to add a tag here, say virtual machine, and I have to point to the folder where there is this JDK 11 installation. So by default you will see that the C program files, Java, and JDK. So this is your installation folder. You need the binary folder. So this is the path. I'm using 11.12. You might be using a different version. Whatever is your version, you please make sure that you bring it back into the INI file. I don't know where my INI file is. Let me just... Okay, so this is my INI file, and I got to put this inside the path, and then of course save this. Okay? So this is one additional step you got to do when you take it from the latest version. So that's why I wanted to caution you. So if you're a good Eclipse developer, you don't even need this warning. You know what to do. Okay? So when you start your again, I thought this one should fix it. Let me see if I have hard coded anything anywhere. Okay, so version requirement is 11, that's fine. Virtual machine. Maybe I should say equal to or something. I thought I can add this in the next one. Let's see. Where I should start. Otherwise, I'll just use an older version and demo. Not a big deal. maybe what I'll do is I'll see what's wrong and then explain it a little later. So for now I'll just use another default Eclipse I have here. Maybe Eclipse. This one is giving me trouble. It doesn't have to be this bad, you know. It used to work very quite easily. Yeah, okay, never mind. Suppose an older version. I just installed it at the start of last year, should be okay. So maybe I'll just browse and pick my default workspace. So maybe inside that's training workspace. Let me just check if this is the right thing. It's too many. Okay, should be okay. So let's give it some time to load. In the meanwhile, maybe I will talk about the APIs. See, what we are going to look at is basically, I'll come back to the concepts here. So what I want to show you is how to set up a very simple producer and how to be able to run the code, and how to set up a simple consumer and how to be able to run the code. It's not very tricky, but the configuration can get a bit out of hands. So that's why I want to show you a demo to see how the configuration is balanced. So when I want to create a producer using a Java application, I need to make sure that I set up certain kind of mandatory properties. So if you look at the mandatory properties, you can see that bootstrap server's IP address, key serializer, value serializer, these are mandatory properties. So you can see that the bootstrap is pointing to 1992. Serializer is a string serializer to keep it simple, and I want to connect it to a producer. So these are the key steps that I have to do, and the mandatory property fields. There are so many other optional fields that I can use. I'll talk about it a little later, but let me talk about the process that you got to go through if you want to create a very simple Java based producer. Number one, you have to set up your configuration. Number two, you got to create a Kafka Producer object, then set up the record, which is your event that you want to put inside, and of course if you want to configure partitions, you can do that. So these are the mandatory things that you got to set up. Additionally, you can put in serializers, you can put in record structures, you can put in send method interface. All these are up to you depending on what you want to achieve from the semantics. So a simple producer file is going to look like this. You have to set up all the properties, like in this case I've set up the server, serializer, acknowledgement, number of retries, what's the memory size that I'm allocating for this producer, how much time you have to keep the linger milliseconds, and then how I produce my data. So the Kafka Producer is basically trying to send keys and values, right? So the key is a string, the value is also a string, and I'm trying to put in a record loop of say 2000 records, and then I'm trying to produce some test records inside, and then I'm sending this to the Kafka cluster. So this is a very simple producer example that I'm going to pick up now to demonstrate. Now, what are the additional properties that you can set for this producer? We have seen how to set up buffer, which we have done in the previous example. You can also have a lot of message semantics in terms of acknowledgement. When you say acknowledgement is 0, there is no acknowledgement for every message that is produced. When you say acknowledgement is 1, the receiver will receive a message as soon as the write is successful. When you say acknowledgement is 2, the producer will receive an acknowledgement only when all the replicas are written. Okay? So these are the three kinds of acknowledgement setup that you can have. And of course, we have spoke about linger and batch size. You can also compress your messages. So yesterday someone was talking about messages which are of very large size, right? I said you will avoid it if you're doing a streaming application. You will still allow it if you're doing a message based event architecture. even in a message based event architecture, you can choose to compress your messages. So that is where you say what is your compression algorithm. So you can point to compression algorithm as gzip, snappy, lz4. There are many kind of standard compression algorithms that Kafka supports, so you can actually configure one of them. And when there is an unsuccessful production of message to the cluster, you can keep retrying. So this is exactly what I was trying to show you in this particular sequence diagram. I said it's like ABC, right? The first thing is linger. The second thing that the producer will do is to retry in case it's not able to reach it. So that's basically what is being set up inside the properties here as well. Okay. So linger tells you how much time it has to wait before sending in the additional messages, how much time it has to try for retrials. And then of course you can see how many times you want your connections to be expanded. If you have a partition logic, you can connect it to a custom partition class, and how long you want to wait before you time out, which is the a plus b plus c calculation. So your timeout must be greater than your linger size plus maximum retries plus some even processing time that you got to give. So you got to make sure that your setup numbers are matching, right? So these are the key things about understanding how to create a producer. Now the same thing applies to consumer as well. Okay? So there are more patterns, like you can have fire and forget, one-time transfer, batch transfer, which means continuously creating producers as well. So I'm going to show you some examples there, a little bit of variation, not too many ones. And of course, if you want more details about how these things are being set, the documentation gives you plenty of examples. So the default is fire and forget style, so we'll see that, and of course I'll give you the documentation gives you pointers on the other two types. Now on the consumer side, what happens is you have created a message. Now you want to write a Java application on the consumer side that will take up all these produced messages, right? So consumer basically starts with a consumer group. Now there are two styles here. So one style is you have a managed Kafka, and the other one is a unmanaged Kafka. What does this mean? A simple unmanaged Kafka is the basic Kafka that is installed. No additional tools, nothing, just like what I have done here. But in an organization where you have a lot of security issues and you want much more reliability, you don't simply use the plain Kafka version. What you'll tend to do is you will use a fortified managed version. So as I just told you before going into the morning break, Confluent is a company that gives you a beautiful managed Kafka installation. So if you pick Confluent server, Confluent based Kafka server, it allows you to have two styles of consumption pattern. Okay. One is a very simple event based pattern, and the second one is the stream based pattern that I was just talking about as theory in the morning. So how does event work? Every consumer will be able to collect all the messages from the producer. So there is this Confluent group coordinator which makes sure that every message is being consumed by different consumers inside the same group. On the other hand, if you're talking about streaming, these are like channels, continuous streams of data, and each consumer is attached to a particular stream, and the stream can collect data from multiple topics. Okay? So a better way to look at it is like if you have a managed cluster, you can set up as simple event services or simple streaming services. Both styles are possible. For now, we'll only look at the consumer on the first round. So when you want to create a consumer, what are the minimum things you got to do? When you produced it, you serialized it. So it is important when you consume it, you got to deserialize it, the reverse process. If you have already compressed it, you have to know how to uncompress it. So that's the reverse process as well. And of course, sometimes you want to do polling, committing, and other lot of additional requirements on the consumer. So if you look into the consumer example, it again talks about the server connectivity. First thing is the group, because inside one group there can be multiple consumers. You talk about deserializer for the key, deserializer for the value. There are two different deserialization. And if you want to commit your reads, then there is a commit flag. So if you want the Kafka to take care of the commit, you have to enable your auto commit. So this will basically keep moving your offset, how much ever messages you have consumed, the offset keeps moving, so that keeps track of how it is consumed. Just like the producer has got a timeout, consumer also has a timeout. So you got to set up the timeout. Suppose you want to have a gap between the message processing, you can also commit on interval. between the message processing, or the delay for the thread. If sometimes it's necessary, you don't have to constantly look for messages that are coming in, so you try to create an interval of rest in your thread. So these are the minimum setup that you do in the consumer. Then once a consumer is created, you consume the message, but there is this parsing part which is interesting. So I have a consumer and I know the record comes in as string and string. So then I have to separate the key, separate the value, and inside the value sometimes I may have to parse them further to a typical record structure and make sense of it. So here I'm not doing anything, but I want to show you how you can parse it into record structure. So you can see that I'm trying to create customer records of string, which is key and value. It comes in. So individual records, I'm simply printing it. So here I'm trying to treat the whole record as a blunt string. In reality, instead of this blunt string, you will be having your own user-defined class. It could be bill, it could be grab, food order, it could be transaction ID of a cash transaction or a banking transaction that you have done. It could be any user-defined record set that you need to parse. And then of course here I'm not doing anything, I'm just trying to print it, and when it is complete, I'm done. And if there is any exception when I'm consuming it on a synchronous mode, I have to make sure that I close my connection. If there's no exception, then I properly commit my pointer that I've consumed this message, and the pointer can move the offset. Right? So these are essential things that you write inside a consumer log. Beyond that, you have additional settings, minimum number of bytes to fetch because you want your consumer to be effective. In case you want to reset your offset, how do you do that? If you want to time out your request, you want to time out your whole session, you can do that. And you can, of course, say how much minimum partitions to fetch as well. So these are additional properties that you can configure. And we'll come into the additional patterns here. So this is the basic setup for a producer and consumer. So let's see how to get that inside. Oh, I've already done that. Never mind, what I'll do is I'll just delete it and then recreate it so that you can see it for yourself. Of course, all of you know how to use GitHub, so I'm not trying to teach you GitHub, but so what you can do is you can go and connect it to Git, okay? So which you can see that I've already done here. So basically you have to clone your Git repository. So you can say that you want to create a GitHub connection, you put in the GitHub details, just copy and paste it, you will get it. Okay, so then of course maybe I can drag and drop a slightly different GitHub to show you how it works. Maybe I'll take another recent repository of mine. So I think last month, what was my class? I don't know. So I'll just take, I was doing a spring class like a month or two ago. So if I want to connect that, I just paste my GitHub like this, and you can see that the connectivity comes in and I can use it. Or if you like Git repository, whatever is your tool, you can connect to your Git as you like it. So you just paste the path of the GitHub and then you get a connectivity. So inside this there are two mini projects. Kafka demo is the plain project, so you can see that I'm trying to import it. Okay? So I can simply say import project and I get that inside. Okay? So I'll just say finish it, and then you can see if you go back to the Java perspective, you will be able to see the project. There could be a problem because of the Java runtime environment. Okay? So you may have to clean and build the project in order for the project to become error free. So give it some time, and then if you look at the packages, you can see that I put all the things I was talking about. So this is basically a very simple producer. So I think the font size is too small. So let me make it readable. Just give me a minute. Java editor, text editor, font size, text font. 10 is too small. So let's keep it as 21 so that it's readable. So you can see that this is basically how I set up my properties. Okay? It's a very simple way of doing it. And then of course you can see that I've created 20 records. So I'm basically creating a topic. Okay? So I'm connecting to my Bootstrap server and I'm putting in some basic message size and using a for loop inside. Okay? So I want to put in a message and a message number inside. Now the same way, if I want to do a consumer demo, you can see that very similarly, the first thing I'm trying to set is the topic name, which is test1. Again, I'm putting in all the properties that I was just now talking about. And then of course I'm going into the records, and then I'm trying to read the records. So this is basically how a basic producer and a consumer will happen. Sometimes you want this to be continuous, you have to start creating callbacks and threads. So you can see that I've given you some example variations of how you can create callbacks and how you can create consumer threads. You can actually go through them, and then of course you can execute them. So here also you can see that I can run my producer demo, and then I can go back into my consumer demo and then read what is inside the consumer. So in this case I've got one producer and one consumer. And I can also create a group of consumers, so I can create one application as my consumer group, and then inside that I can have multiple consumers. I can start polling different consumers, so you can see that I'm trying to create a few records, customer records, and I'm trying to create parallel threads of consumers to be able to consume in parallel. So this is also possible. So when you run the simple test, you will be able to create a very simple functional not this one. If I create my producer demo and then if I run my consumer demo, you'll be able to see it. So you've seen the basic producer code, right? So let's try this out. So I'm going to say, where was I? Okay, so I'm going to connect to topic test1. I'm going to put this message inside. Okay, so let me see, right click. I'll just say run as Java application. So this basically will allow me to put some messages into the test code. So you can see that it initializes a connection with my Kafka. It should give me an error because I'm not running my Kafka servers yet. So let's see how the timeout happens. So it's basically trying to connect. It keeps on trying. Okay? And I'm not trying to give any whole timeout. I'm only giving message retries. I'm not given a whole timeout setup here. So you can see that it endlessly keeps connecting. Okay? So the best way is to stop it. And if I give a timeout for the whole series here, after maybe 5 minutes or whatever is my timeout, it stops. You can test it for yourself. So what I'm going to do is I'm going to go back here and start my Zookeeper. So I'm going to say Zookeeper. I'm sure this is inside some of my, a bit lazy to type everything. So this is my Zookeeper. I'll start that, and then of course I'll have another new PowerShell, and then here I'm going to run my Kafka server. So I started my server as well. So this basically means there's an active messaging system run. So you can see that it is basically going through the existing topic and it's ready for me. So if I now try to run my producer again, so I'll just say run as Java application. I just created 20 so that I don't have to do an exhaustive 2000. So you can see that there are 20 messages and all of them have gone inside. If you want to see how it is working inside Kafka, you can open the offset tool here, as I mentioned earlier. You can also use Kafka drop. An ideal way is to use Kafka drop because I don't want to overload with Docker. I'm just using this. So you can see that it can connect to the local cluster. So if you go into the topics, you can see that test1 is now created. If you look at the test1, it has got only one partition because I asked for only one. And if you run the data sets, you can see that you have got 20 messages inside. So this basically means that there is a producer and then there is a topic test1 and the data is filled in. So now if you try to run the consumer demo and then right click and say run as Java application, you will see that it basically connects to the same server, same topic, and it is basically picking up individual messages and it is trying to print it for you. Okay? So you can see that it basically is able to connect, successfully read it, and then print them as well. Okay, so that's basically how the consumer and the producer works. It's a very simple example, but this is how you have to programmatically do everything that you want. But in reality, do we do this? No, right? So you would like to have a slightly better setup for these things. Okay? And what do I mean by better things is all these properties that you are creating, both in the producer and consumer, you would like to have them come from property files, okay? YAML files, property files, and you would like the programming framework to help you handle them. Okay. So many times you won't be able to directly code like this, unless it is necessary. You're not going to use plain programming languages to write applications. You are going to use, in fact, setup that is already being held in place, and then you start using them. So very likely all these property files will be in your application framework. You'll write them in the application.properties, and then from there you will use it. The second demo that I'm going to show after we discuss some concepts is about how you do that. Okay. So I'm going to try to show you how you set up a very simple web application, Java web application, be able to write all the properties inside, and then be able to ask the language and the programming framework to call the same setup, and then be able to help you implement them. So that's the part of the second segment of demo. So but we have some concepts to clear before that, but this is a very simple way of interacting, and it is possible for you to use any language that I've listed on the workshop. Because I wanted to show you one flavor of it, I'm picking Java and then demonstrating it to you. The same thing can be done in any language. So maybe I'll stop the recording for now, and I'll continue in the in order for us to look into the case stream demo, I thought the very best stream to work with is Twitter. So I'm trying to connect Kafka and Twitter together to show you how it works. At start, I'll simply use Twitter and show you how the streaming and parsing works. Then I'll show you how a Kafka Producer will work on the same Twitter. Then I'll show you how the Kafka stream will work on the same Twitter. So you can consume it in 3 different fashions. If you're simply using the developer's API, right, so you have full documentation, tools and libraries. So you can see that the complete Twitter also has its own API. So you can consume Twitter directly into any language of your choice. So you can use JavaScript, Ruby, Python, Java. Every language is almost supported. So you can look at your language support and what kind of tool you can use inside the documentation library. But I'll directly jump into the demo example. So if you see, I have this code which is called as Twitter filter. Okay? So here, if you look into the libraries, I'm not using any Kafka libraries. I'm directly consuming the Twitter developer API. And if I want to use this Twitter directly, I need something called as the bearer token, which is basically an access key. Okay? So what I have to do is I have to set this up inside the environment variable. So as usual, if you go into the Windows Explorer, we were trying Eclipse. So select your PC, right click properties, and then of course, sorry, where is my PC? Sorry. Okay, properties. Then of course I go into system environment variables. So if you see, one of my environment variable is called as bearer token, and I put the token number from my Twitter developer I was just now talking about. I put the bearer token here and I've set it up. Okay. So at any point on time you can open a command prompt and then see if it is working. So you can see that echo percentage bearer token percentage, you see that there is this token that is existing. So it should be in the environment variable. So once you have it inside the environment variable, you can open up and then you can connect to. Okay. So the first thing I'm checking is whether the environment variable is properly set. If it is set, I'm going to use that to connect to my Twitter API. And here you see I can set up any number of rules. That's what is interesting about the Twitter API. So here my rule is I want cat, I want Twitter messages which has got the word cat, and it has images. Okay. So I'm looking into tweets that has got cat in the tweet feed and some images attached to it. I also want to look at dog, so you can keep increasing your rules that you want to look at. So, and then of course you can see that you need to write a lot of handler codes. I'm not going to walk you through the code and bore it because it's all dependent on the HTTP API from the basic Java. So you can see that what happens here is I'm basically trying to write a connection stream to the Twitter API directly. I set up my rules, then of course I created the rules and then I set up my rules, and then I fire the rules, and at any point I can say get rules, and I can format the data that comes back, and I can print the data as it comes. Okay? So there are a lot of utility classes that I'm writing to just clean up the tweets that come back and then be able to show you what is happening. So once I've connected to the direct API stream, it starts working. Okay? So that's exactly what I expect out of the direct Twitter API. So if you want to see how this executes, so if you take this Java application and you run it as a normal Java application, So you can see this is my bearer token, and then from then on you can see that it basically picks up a lot of tweets that's currently happening with the oh, what happened? Okay, it takes some time. So these rules are being sent, so it is going to go and grab streams that has basically got cat images and then dog images inside it, and then it starts printing all the tweets that comes back. So you can wait for a while, and once you start getting images of or tweets that comes with these kind of images, you can go and Google for it and see if it is valid. So this is a very simple API structure that basically allows me to be able to connect to Twitter feeds directly and start processing it in my own Java language. So this is a very simple approach. Now the same thing, I'll wait for the console to come back. I hope there's no authentication error because just now it was working. Oh, metadata. Okay. Let's see. Did I put any thread? No. I didn't no thread. So by right it should come. There's no problem, so the connection is okay. Maybe there's nothing like cats, dogs at the moment, so let's wait. I was just now having some appenders. Maybe my topic is full, or I don't know. Okay, so this is my Twitter. Let me see. Partition. Oh yeah, I'm getting a lot of tweets, but okay. I don't have it printed yet because I've not passed them to token. I should be able to see them on the screens. I don't know why it's not working. Let's try again. I hope I don't have any partial threads. Okay, so Twitter stream. Let's see. So it's basically profile for the images. It should come back. So let's see. Let's wait for the messages to come back. So I'll leave it as is. I'll go into the Twitter producer. Now what I'm trying to do here is, if you see, instead of using all the utility classes, I'm going to use Twitter's wrapper classes, which is Twitter for Java. And then I'm going to use the Kafka Producer and the Producer record that we just now saw in the Producer example. So if you try to write a message directly via the Kafka Producer and you start working with that, what happens is, you have to create all the tokens that I was just now talking about. So you've got to put in your consumer key, your secret key, your access token, and of course you have to create a topic where you would like to collect the Twitter's tweets individually as events into my Kafka Producer. So you can see that I've set up the consumer key and all that. And then of course I built my configuration file, and then of course I want to query. So here what I want to do is I want to see all the query topics that is related to Cloud Native Cloud Foundation, CNCF, one of my interests. So I want to see how many tweets are there, and I want to pick Indian English, and then see how many tweets are there. So of course I want to only pick 10 tweets from here, and then I want to just print the tweets to see what is inside. So very simple. Or if I want Singapore English, I have to say SG English and then save it. The reason I have to flip is not many developer talks happen in Singapore tweets. I tested this before, so I thought I would pick a bigger country where we have more population and hence the possibility of more tweets. So that's why I had to flip it like this. So let's see how this works. So in the meanwhile, you can see that the direct stream is picking up a lot of tweets that has got these rules. So somewhere in the message you either have a dog or you have a cat. So for example, you can see that the dog is this is basically a tweet that is being retweeted by many people. So it's a common tweet. You can see that somebody, if there are no dogs in heaven, so you can actually look for this particular person. Okay, so if you go and search for this particular tweet in the Twitter, you'll be able to find them. So this is a very simple direct API that keeps working, so no problem. The only thing is, if you look at the tweet stream, you have to use a lot of builder API, and you are trying to deal with data as JSON. So you're basically trying to write HTTP request, response, post. So every time you post something and you get a response, you got to parse through the record, understand it. So it's a lot of laborious work. But on the other hand, if you look at the producer also has work, not bad, but you still have to pass in all the credentials. Once it is done, you can see that you can directly deal with the records. So the producer records are your individual tweets, and the tweet data comes in as a string, and you can simply print that, So you can see that event processing is one step better in the Twitter. So let's try running this producer to see if I get some 20 tweets on this. So I'm going to say Twitter producer Kafka Twitter Producer run as a Java application. I got to stop this first. Okay, so I'll take the producer and then I'll try to run that. Okay, so Java application, and you will be able to see that it picks up 20 tweets. Okay, so it's very easily it does that, and you can see that I'm interested in CNCF, so all the messages that it has picked up will logically have CNCF inside as well. I think I'm putting an infinite loop. Let me try. So it's a while do loop. It goes on. Okay? So you can see that there is so much traffic on CNCF. Maybe you can look at what is trending today and then see if you want to test that as well. But you can see that individual producer records are coming in. So I'm going to stop here to see how my Kafka offset tool is trying to look at it. So this is my Twitter, this is my partition 0, and if I look into the records, by this time I have basically collected around 100 tweets, more than 100 tweets. So in a short period of time, you can see that each of them come in as producer records. This is the second style. The third style I want to talk about is the stream, which is what is very interesting. When I want to deal with Kafka as the stream, I really don't need the bearer token. I don't need the credential business because I'm not using a developer API. I'm just using the public stream. I'm scraping directly the public stream and I'm processing it. In fact, this has got the least privacy objections or anything. So whenever you are trying to develop, you're working with streams, you will see that in industry, developers prefer to use Kafka Stream because Kafka Stream libraries come with a lot of inbuilt facilities. What are the facilities? The stream comes with a basic class called Kafka Stream. It helps me to serialize and deserialize as I want it, serializer, deserializer. And of course, you can see that what is being consumed can be converted to record structures quite easily. So you can see that I'm not putting any credentials like the other programs. I don't have to configure anything. I just have to say, what's my Kafka server like? What's the bootstrap address? And that's about it. I create a stream, I connect to Twitter, and I look for the same cloud native, cloud foundation value. And I put a sleep thread because I don't want that to, sort of overshoot my existing topic size. So I've just put my thread size as certain, I'm putting 35 seconds, So you can see that it's quite simple, straightforward. So dealing it with stream has got a lot of advantages as compared to dealing with it as producer, consumer, and so on and so forth. So that's to differentiate between the APIs. Otherwise, all of them look the same to you. You can look at the way that we code. It's greatly simplified, and any public stream can be converted into K-stream and you can start processing them. You don't have to store everything. You can do on-the-fly computations and then leave your tweets. So that way you can see that it is the least burdened Kafka cluster processing that is possible. So let's see how this runs. It's exactly the same way. So if I try to read this as a stream and execute this as a stream, so I'll run this as a Java application as well. So you can see that, it actually connects. There's no necessary for any credentials, right? And then it keeps on continuing all the messages for the 35 seconds, and once all the processing is done, it closes. You can go back and check on the offset. You will see that it would be done. And this is what is the best part about dealing it with streams. Of course, if given time, if I have another half a day to spend with you, I'll probably show you how the streams can be processed. So here you've just started and closed the stream. You're not done any processing, but the stream can do computations. You can select, you can filter, you can join. You've got a lot of operators that you can apply on the K streams and then process them. And of course, you can even fire queries and machine learning algorithms. So for lack of time, I'm not going deeper into that, but I'm just mentioning what is possible and I'm stopping there. So you can see that it basically worked for 35 seconds and the session has closed. Okay. So this is how you compare yourself. Okay. So this is something that I wanted to talk about on Kafka Producer and Kafka Stream comparison. So I think that's good enough. So let's